Hello, everyone. Welcome to this week's episode of ClueCon Weekly, sponsored by SignalWire. This week, joining us is Neven Boyanov, CEO and founder of Tinozar, a very interesting company that's providing all sorts of IT technology and embedded training for kids and children. It's very, very interesting. I'm a parent and I'm super interested to learn what you've been doing. Thank you, Neven, for joining us.
Thank you.
So,
So,
before we start, could you give us a quick introduction about yourself, what you've been doing?
for the past 4 years, I'm 100% focused on education and the Tanzor project. Before that, there are a lot of things that happened in the past, without exaggerating, past 30 years. I started my career in high school. This is where I decided, this is when I created my first business. It was a very small business, but I've been an entrepreneur most of my life. I run different companies in very different fields, including machine translation from one language to another, mobile software, and things like that. Little bit computational linguistics, some cryptography, and since 2013, I work on the Dinosaur projects almost exclusively, and especially for the past 4 years, that's the only thing that I'm doing.
Wow. So, I mean, machine translation is, well, it's still a very important and complicated technology field, but that's far away from education and
Yeah,
getting children to learn about computers. So, how do you get there?
actually,
What
I
was the
started.
journey?
Yeah, I actually started my journey in science even longer time ago. When I was in fifth grade, I found some old textbooks um, in my grandparents' old house. It was physics and chemistry, and I got really interested in science because they have great pictures. Those were old textbooks, my mother's textbook. And then I learned about electronics. I learned some circuits that I can make. Actually, crystal circuit, crystal radio, and things like that. And then around 80, 84, the first computer in Bulgaria was created. It was not widely available, but there were a few places in the country where you can go and start uh, programming in BASIC. So I was combining all the time what I knew from physics and chemistry and other sciences with programming. That's why when I, graduated university and I started teaching some classes in a couple of schools here in my hometown and in our university, I I figured out that children and students don't know how to combine everything that they've learned in school together to create things. And the funny thing is that once you finish your study in school or university, you go to your first job, and what you're asked, it's exactly that: combine everything that you know from other sciences, from mathematics, physics, chemistry, whatever you've learned, and create things as part of your job. And you've never learned how to do that. So I decided I have to do something about it. And actually, with the help of some colleagues in the university, we created a course that combined microcontrollers because it's funny, because it's interesting, it's popular. Also combined with some robotics. Of course, there are algorithms, so we can apply computer science and some mathematics. And we, over the past several years, we started using that in some schools. I started teaching classes there also, and over time, I created a lot of lessons for myself. Of course. Then I realized that some colleagues of mine, other teachers, want to use that as well. I did some training for some friends. Then I decided that maybe I should start this as a small business. We run four crowdfunding campaigns since 2014, I believe. And in 2018, someone approached me and said, "Hey, is that a business that I can invest some money in?" And I said, "Well, there is no company yet, but we can create one." So we quickly created a company. Then another person joined in, they invested some cash, and we decided that this is going to be a business that combines open source software and hardware education, and of course, sort of sustainable business model. So we don't have to work other things. We will focus just on that. And today, um, our product, our projects is probably three main things. It's the dinosaur boards, the lessons for students that teachers can use. And the third component, which is very important and very unique for us, is the training for educators. What we've been doing for the past 3 years, teachers, mostly from Bulgaria, come to us and we do quite an intensive training, which is about 2 weeks. They learn how to use the platform, how to teach students our multidisciplinary curriculum, how to use different subjects like physics, mathematics, programming, combine all that together, mix in the entrepreneurship, soft skills, and things like that, and have what we today call STEM. It's a bit broader than STEM, but and they are very happy about it. It's one of our services that keeps us sustainable, keeps the business running, and when they go back to school, they can just go in class and transfer that knowledge to the students. So this is what we've um, created as a business, and we still keep the software, most part of it, and the hardware open source. So if you can, for one reason or another, if you cannot afford or you don't want to buy any of our products or services, you can just go order all the parts yourself. Maybe create, make the PCBs, the printed circuit boards, solder everything, and learn how to program it yourself. But if you're willing to help us to support our efforts, you can join one of our courses.
Nice. So, well, some technical questions first. What exactly is Tinosaur? Like, what is the platform based on? What kind of a chipset, etc.? That's always interesting.
Thank you very much. Giving me opportunity to show all is that what it's all about. So at the beginning of the school year, each student will receive a package like that with electronic parts in it. We will give them soldering irons. Actually, we use 5-volt soldering irons. They're very safe even for youngest children. And they will start soldering all the components on the board themselves. The same way real engineers will do while they're in their R&D. So they will create small board. I have one here. It's very small, looks like that. Actually, I have another camera here that I can show you. Can you see? Yeah, you can see that's the board. This is what every student will create. There is a microcontroller here. It's 80Tiny85, which shows probably the simplest microcontroller for various reasons. And one of the reasons is because it's that simple, very few things could go wrong while they're soldering, and it's very easy to learn how to program it. That is very important for us because we don't want to create things too complicated. We want to have 100% success rate in class, which means everyone to solder the board and to have it running successfully with the software. So once you have that, it's yours. It's very exciting. It's yours. You know every little solder, what it looks like. And actually, you don't even have to write your name on it because when you look at it, you say, "Oh, I did this." That's mine, right? So they keep it after school, which is very different from many other products that kids live in school. They keep it. They get it home. At home, they will show it to their siblings or their parents. You won't believe how much parents love it when they see their children doing something like that, especially if the parents are engineers. They will say, "Well, while I was younger, I was doing that. Today, no one is doing that." So they get really excited. So we do this in school and also in some tutoring sessions or private courses in learning centers. People actually buy the kits for various purposes, including doing some activities at home, children and parents, because with other products you just connect batteries and wires and that's it, and you have to go to the program. While with this, you create something, you don't know what you can do with it. because there is a lot of possibilities. Well, not that many, but enough to be interesting. And then you start to learn how to create programs. And I can show you how we do the programming. Correct?
So,
Yeah.
what languages do you support for programming on the AT-Tiny 85? I know the AT-Tiny is very, very versatile. You can do a lot. I probably have half a dozen boards built around it.
Yeah.
I usually make them from scratch. So, what are the options for developing on it?
It's C language, not even C++. Of course, you can use Arduino, but we prefer to learn the C language because it's one of the most important languages. Once you learn C, you know half of other languages that exist. So we want to teach students to program in C language. It has only 8 kilobytes of memory for the code and 512 bytes for the data, and another 512 for some. It has a ROM memory. It's very limited, but that will encourage you to make your programs very efficient. One of the greatest advantages is that it consumes very little electric power. It goes below 1 microampere, something like that. But for children of age 9 and above, we don't code by writing the program by hand. We created our own block-based development environment where you will move little blocks, and this is how you're going to create your program. I can actually show you.
Oh yeah,
how that works.
I would really love to see it. If you have a way to show
that's our block-based development environment. You move around blocks. There is something that is called Scratch. A lot of people are familiar with it, but that's our own. And I will tell you what is the biggest difference. In Scratch and other similar environments, you have very high level of blocks that do a lot of stuff. Ours are what you will see in a C language. In other words, if you have here if, do, that is exactly what you're going to do if you write your code by hand. And the other thing is that here you can look at the code that is created. So when you move the blocks around, the code, of course, will change. And the curious kids will move the blocks. They will see how the code is changing. And one day they will just switch writing code. So our goal here is by moving the blocks around, you will create a program that looks similarly to what you will do in C language, except that you're not going to put the C language commands by hand. You will do it with the blocks. Why? Because everyone that is teaching classes programming for younger children, they know that sometimes half of time in class it's to close the brackets, to put the semicolons and other things. Because that takes so much time. Here we don't have
even beginner adults have that problem. Like even if you're teaching someone that's an adult, that's hard to do.
So if you look at that code here, it's very simple. When you press the button, it will light up one of the LEDs. When you release the button, the other one will light up. And when you look at the code, it's the code is well formatted. You can see what it does. There are no abstract commands or functions that do everything for you. You will see that you're using here bit operations and things like that, and you can start learning more advanced programming. And of course, that platform here has a different mode where you will switch to text editor, and you can copy paste that code and change it and go to the next level.
Nice. That's okay. So I think the block-based programming environment is something that children are accustomed to. Like my daughter does that kind of. They use Sketch at school and get started. I tried to teach her Python, so we're all we're trying to get to the next level. So just curious, what kind of sensors and accessories does the platform have or ship with? What can you build around it with? Of course, you can probably add anything you want, but what are you shipping with? Like, what can I do when I start?
In general, you can do a lot of stuff, and you can add a lot of sensors. But what we start with are two additional boards. Let me just show you. So that's the main board, and you also have
Okay.
one additional board with two LEDs, and actually that covers maybe 5-6 lessons because you do blinking, you do pulse width modulation, even pulse width modulation. You can do some tapping code, which is similar to Morse code, but it's much simpler. You can do, of course, traffic lights. And we also have a board with three LEDs, which is sometimes we use, sometimes not. But we also have the second shield board that you put them like that here.
Yeah.
Where you have a buzzer, you have a light sensor, basically a photoresistor, you have an LED. And here you can you can connect sensor, servo motor, but that's for the next level. At the beginning, we want to focus on the basics. LED, which is output, buzzer, which is audio output, a button. I often make a joke with children that we have a keyboard on our computer is just one button keyboard, which is
Yeah,
the
it is what
tactile
it is,
button.
for sure.
Yeah, and also you have the photoresistor. So we have two inputs and two outputs, and we can do a lot of stuff with that. So with that board, one of the relatively complicated things that you could do is an alarm because it has a light sensor. You can put it in a box. Someone opens the box, the alarm will go off, and unless they press the button in a specific way, let's say 2 clicks or one long and one short, the alarm will not turn off, things like that. So that's actually everything's project based. We have methodology that we develop, which puts the goal in front of everything else. So you have a goal, you have a problem to solve, and then you acquire the knowledge necessary to solve that problem. That is actually one of the basic things of our methodology, because otherwise you don't know why you're learning that algorithm or that physical phenomenon. We want to put the goals before that, so children will have the motivation to learn what we want to teach them. So that's how it works with us. It's been working very well. They're very motivated. Everyone knows that children don't always have the motivation when they're in school. Sometimes subjects are boring. Sometimes they don't even know why they are learning them. So we're trying to do that by those projects. And talking about projects, we have other projects that are more complicated. One of them is the solar panel. I think I have here. I have a box of projects here. And one of them is that's the solar panel. So you have a solar panel view that will charge the battery. On the bottom you have servo motor. You have the light sensor here. I don't know if it will run right now, but it will move the um, the base like that, and it will search for the best light in order to charge the battery most efficiently. And it will do that every 15 minutes, and it will
So
will
that's
position
that's a
you.
miniature that's a miniature real solar concentrator. It's quite
Yeah.
interesting. I mean, we've
Yeah.
all seen the big ones. There's I live in Italy, and we have
Uh-huh.
a lot of hills that are covered with those large solar
Yes.
panel arrays that turn around. It works according
Yeah.
to the same concept. So it's brilliant. It also teaches kids about renewable energy in a sense. It's you can learn
That is a
how solar power works.
Yeah, that is perfect school project because you
It
will
is.
learn a lot of stuff that you will learn in school anyway, like mathematics, algorithms, programming, physics, and also you will have a project that you can present at some competitions. You can put it somewhere in a school, and other children will see it, and they will know why they're learning all that stuff. That's why I really like that project. Of course, we have a car. Where is our? It's tiny. It's really small car. It has the sensors on the bottom, and it, of course, it could follow a line. Also, we have a game. We have a display. It's with very large pixels,
Yeah.
and it's also very low resolution. But you can program a simple game, and actually, that is actually I was surprised to learn that children like that game more than the car. It's probably because I'm a bit older and I like things that are moving, while children will like the game much more. So it's just one button and you have to stack all the.
Oh, yeah.
Yeah, it's very simple.
Nice.
It's very easy to program it because it has one button, one buzzer, and one display. That's it. There are no complicated things because
It's almost Tetris.
it's actually the opposite of Tetris because Tetris you have to find the empty spot and put the block there. Here
Yeah.
you have to stack them. I think it's called Stacker. The game is called Stacker.
Oh, yeah. You're right.
Yeah, something like that. Of course, we have the mechanical stuff. You have the lever here. You have the servo. You can move it, and there is a Hall sensor. I don't know if you can see, but yeah, there is a Hall sensor here that can tell you where is the magnet. That could be a parking barrier, could be a door opener. So we do the mechanical stuff as well because if it's just light and sound, it's interesting, but not enough. You need to have more things that you can add um, to the project. So different children will like different things. So we want to give them opportunity to play with different things, mechanical, sound or the little games.
That's really
That's what we
those
do.
are really those are really interesting. So I was looking at your website. Those kits are not available through the website, right? Only the baseboards for now.
Yeah. I will tell you why. Because right now we don't have enough video lessons and user guides for those additional products. Because only teachers that are trained by us could work with them and teach you how to do them.
Mm.
We're currently working on shooting those videos, so they will be available on our website. We want to make sure that when you buy the kit, there is a very good user guide. Actually, just for the main board, it's 100 pages PDF file, every single step. I don't think there is even one person that could not assemble this themselves because
Yeah,
it's very detailed. You have to put an effort to do something wrong. No.
yeah, it can be not.
So
Okay.
yeah.
It's certainly
So we
not
want to make
not.
sure that we have all the documents before we put something on the website on sale.
Yeah, that's a very good point. It's not just enough to put things out there, but they have to be
Yeah.
usable, and people have to be able to get started the right way for sure. How many students have you worked with so far? If you can, if you have a number.
I don't have the exact number, but let's say several hundred students each year go to our courses here in Bulgaria. That's students in schools, in our we do summer camps. Oh, that's very exciting. Every summer for 3 weeks, children come to a summer camp here in the mountains close to our town, and they spend 1 week doing just that, assembling boards, playing various games, then doing some programming, playing again games, watching movies, discussing about future because we show them movies about the future, about the technologies. They make new friends because they come from all over the country and sometimes from other countries. And at the end, they have something in their hands, of projects that they can take home. That's great. There are about 30 children each week. We are planning to expand that and to go to other countries where we can train. Actually, this is what we're trying to do. Get to know people in other places in the world who really like what we do, and we can train them. We can provide them with the materials, the content, the videos, the kits, so they can do the same thing where they live in their community. And I think that's the only way we can grow and be sustainable and keep creating new projects.
So when are you coming to Italy?
Oh, of course. Well, I don't know if it's a funny story, but last year at educational conference in London, VET Show, which is the biggest, it's more like a trade fair for educational products. One guy from Italy came to our stand, to our booth, and he was friendly, but he said, I'm from the town where Arduino was invented, and what you're doing, it's not worth doing it. Just go and buy Arduinos. He said, if you come to Italy, everyone will tell you that. I don't know if it's true, probably not. But people, those that are too much involved in Arduino community, may think that everything else that is not Arduino it's it's a bit of a less worth than Arduino, but ours is simple. That was our goal. For professionals, Arduino is simple, but for the beginners, Arduino is sometimes complicated. So we want to
Yeah, you're
make it
right.
very simple.
You're right. So I'm a professional. I used to do embedded work for a long time, and I usually
Yeah,
build my own boards. I To be fair, I've taken a liking to the ESP32 chipset recently, which I've been
yeah.
using
Oh,
for most
it's
things. But
great. Yeah.
even just the 18 mega family, I just build them myself. Well, yeah, getting someone started on a pure Arduino is not that easy. There are a lot of simple things that if nobody tells you, you won't know. You're totally right.
Yeah.
There are a bunch of things that getting started, an easier way to get started will probably be better. Plus, if you're 9 years old, Arduino is difficult. To be fair,
Yes.
so I mean, I can get you to light up an LED, but that's it. It's really
Yeah,
too
yeah,
hard.
yeah. Look, there is another thing that most people don't realize, but 90%, if not 99%, buy their Arduinos from Far East, from well-known websites. And
Hmm.
you receive a plastic bag with bunch of boards, and you don't even know what to do with those boards. And that's it. You have to find someone to help you with that. What we're trying to do is create a package where when you buy the product, you have everything that you will need for that board, because you can pay $5 for Arduino board, a knockoff, but what are you going to do with it? You still need someone to teach you everything, how to connect it to the computer. Sometimes it will not work because it's not 100% compatible and things like that. Most people, unfortunately, don't buy the original. And people who have created Arduino put a lot of effort in that
Mm.
project,
Yeah.
but most people just don't buy it. That's
Yeah, the hard part is getting the right hardware first. That's important.
yeah,
I
yeah.
plus you're totally right. People buying from well-known websites, the you often get you don't even know what you get. I've seen people coming to me
Oh,
asking for, what do I have here? And well, you simply bought the wrong thing. Like I had someone who bought those large voltage regulator circuits. There's a
yeah,
if you need to regulate 12 volts, etc. They're quite big, right?
yeah,
There's so someone
yeah.
bought six of those instead of Arduinos. To this day,
Uh-huh.
I don't know how this friend managed to buy six voltage regulator boards instead of an Arduino of that website. So yeah, it's
It's
it's hard to.
it's probably not their fault. We are buying tens of packages every no, maybe yeah, tens of packages every week, because that's how we buy some of our parts. And sometimes even we receive wrong parts. The suppliers, or their traders, not even suppliers, the manufacturers, sometimes they don't know what they sell. They will just get something from a box, put it in a bag, and just send it. They will rather refund me rather than check the parts if they work. Actually, recently the USB programmers that we are using, those USB ASP devices, around 2 to 5% uh, come not working, and we have to test them here. And I have no idea why they don't work. I think they just stopped testing the what they are manufacturing. So it's
My
difficult for beginners.
my brother-in-law, is doing some research about detecting pressure in hospital equipment, in breathing equipment,
Uh-huh.
and he bought, I think, 50 HP 180, those simple pressure
Uh-huh. Yeah.
atmospheric
Yeah.
pressure sensors, and I think 20% of them were defective in some way. They worked, but the reading is so far off. So every time they get one, they have to test it. Quality problems are very real. So that's part, because a beginner won't know. Like, so you get a sensor that's defective, you will probably not
Yeah.
even find out. I mean, an LED that's defective doesn't light up, so I mean, it doesn't work. You can tell it doesn't work. But then,
Yeah.
how do you know it's not lighting up because you're using it wrong, or is it not lighting up because it's broken?
Yeah.
So yeah, beginners need to be sure of the quality of hardware. So that
Yeah.
I wholeheartedly agree. Makes for a very much better experience.
Yeah, yeah, and you are absolutely right that there are some adult beginners, and they have the same problem. Actually, we have here in our learning center a guy who is about 35 probably, and he decided that he wants to learn programming for microcontrollers, and he's coming and he has the same problem and issues like 9 years old. It's difficult.
Yeah,
So that's what we're trying
really.
to do, help the beginners, because I think we will need more engineers in the future, because we start our courses with a lecture about jobs of the future, because in the future, near or distant future, most of the jobs that does not require to think or to create things will just disappear. And you have to be more creative. You have to be smarter. You have to be better educated. And if children who are right now in third or fourth grade don't know that, and if their parents don't know that, they will have big problems 10 years from now, because when they go to the job market, they will be surprised that everyone else is well educated, they know how to create things, how to be entrepreneurial and things like that, and they will lag behind. And what look, there is something that I want to do for my country and maybe for many other people. I want to help people start creating businesses here, bring back the manufacturing here, invent new things, create new products, create new businesses, and sell products on the market directly, not just buying stuff from those websites and just reselling it on Amazon.
Yeah,
And
that's
we have to start doing this now. It's they say the best time to start this was tomorrow, and the next best time it's now. So we have to start doing that. And I think um, it's not only us. We're not the only people who have that mission, to educate children. There are many other people, and I'm really glad when I meet people like who are like us, and we try to collaborate. We very seldom see other people as competition, other businesses similar to us as competition. We are thinking about them more like potential partners, because it's a big market. It's how many billions are on Earth? 7, 6, something like that. So
Hmm.
there is enough people on this planet for everyone. So we should collaborate. We should help each other. To create the inventors of the future, because we have to create it. They're not going to create it by themselves.
I feel like this is very much the spirit where people, when people are building open source software, that's what they think. But we have to remember there's also hardware, and it's as important. And
Yeah,
it's incredible. It's becoming more important because the whole IoT.
yeah,
There's a bunch of interesting things that are coming up. So knowing how to do embedded work is really going to be
yeah,
helpful.
yeah.
Great. So, Neven, thank you so much for joining us today. It was a different discussion than usual, and as a parent, I really appreciate what you've been doing. And well, if you ever want to come to Italy and maybe try and do something around here, hit me up. Anybody needs anything, Neven's website, it's tinusar.com, Tinusaur, or Tinosaur, like dinosaur with a T. And
And you,
well, and thank you so
thank
much. It
you very
was,
much for the opportunity.
and well, for the rest of the people, I'll see you next week. Goodbye.